Okay, so welcome to this another special edition of ABNcast, recorded at the Farnborough International Airshow. We are on the stand of Hexagon now. Hexagon is a company that manufactures some of the most leading, most high precision measuring equipment that are used by airlines and MROs. I'm joined by Aziz Tahiri, who is the Vice President of Aerospace and Defence at Hexagon. Aziz, thanks for inviting us onto the stand. We last saw you in Paris at the Paris Air Show last year, and you were demonstrating quite a lot of the technology that's behind us. We'll see some of that in a minute. Just give us an overview of what it is that Hexagon does and why it is important for an aerospace company, for an MRO, to start to adopt this sort of technology that you are developing.
Yeah, well, thank you very much for coming over. Always a pleasure to have you on our booth here, and being at Farnborough must be place, right?
Yeah.
So I guess when we talk, we already mentioned the backlog, twice more aircraft needed flying within the next 20 years and so on. All these aircraft are going to pile up into MRO, and downtimes needs to be reduced in the MRO.
Yeah.
Today, when we talk about inspection during the maintenance checks, we're talking mostly about people walking around with flashlights, looking with their eyes, scratching the surface, eventually taking some pictures and having to assess the damages.
Yeah.
What we do, because now we have such lightweight equipment, we can go and actually scan the surface of the aircraft with the accuracy that's needed to assess the defects that have been most likely initially already spotted.
Yeah.
Because if you have to scan the whole aircraft, that would be maybe too much of a stretch.
Yeah.
But if you can actually spot something and go in there very quickly, without being a metrology expert, scan the defect, characterize it, and be able to assess the effect of the defect and predict a little bit, how critical it is.
Yeah.
That's a game changing.
What we'll see during this segment on the stand is precision measurements, firstly. Then we'll see about what automation can do for companies, and then how to create a digital twin to ensure that you're operating at the highest efficiencies as well. Because that's key. And all those three things are addressing critical needs in the aviation sector today, aren't they? Because of that sort of crunch between supply and demand when it comes to MRO and the amount of facilities that are out there. You can only build so many facilities, and everyone's trying to make the most of what they've got today. So this is why this is crucial.
Absolutely.
Yeah.
Absolutely. And the first step is really here, quick, easy scanning for defect location and characterization.
Yeah. So before, what have we got behind us here? This looks like something out of Star Trek or Star Wars or something.
It is.
What have we got here?
Well, it's laser scanning. So you're quite right talking about Star Trek. Now, that one is very lightweight. It has multiple scanning lines. So you can scan quite a large surface quite quickly without having to put any target or any specific on the aircraft. So this way you don't have to remove them, install them, scratch the surface eventually. So quick, easy to use, lightweight, 3D scanning equipment to see what your eyes can't see.
Yeah. And this is obviously, it's mobile. So you'll be using this as an engineer, aircraft on the ground. Something maybe has happened on landing or something. So you can go out there and scan the issue.
On-wing inspection, flight control panels, leading edge, trailing edge, air inlets, landing gears, doors, cargo doors, all types of, I would say, of vulnerable surfaces when you fly an aircraft that are likely to be hit by a bird or an ice.
Yeah, okay. And this is full of scanners. These are all scanning the surface.
Yep.
That information is then being pumped back into the system, so you create a 3D virtual copy of reality, which you can then use to decide what to do next with that problem.
Exactly. The scanner is in the middle. Everything else is more to localize the device towards the object that's being scanned.
Yeah.
And all the data is being pulled into our software, where we do the analysis and then check it against what it should be, the nominal, and try to assess what needs to be done.
Yeah.
Is it okay? has it progressed? How fast? Should it be repaired? And then eventually we'll go one step over about what's the best corrective action.
Yeah. I know because you very kindly invited us to the Red Bull HQ last year for an event, an aerospace event. You went there.
Yep.
A lot of your colleagues were there. So they use this sort of equipment and another measuring equipment that you produce. Because in Formula One, obviously the key thing is to be able to measure things to within a micro hair's breadth of it to make sure that they are within regulations and also they are optimizing their performance.
Yeah.
So it's an interesting crossover between that sport and aviation. Are the two learning from each other so that the aviation industry can see what's going on in Formula One and adopt those techniques and those procedures?
Yeah, you just mentioned two things that really are what keeps us on top of the worldwide provider for such type of quality control equipment.
Yeah.
Speed and accuracy.
Yeah.
We want our customer needs to produce, not to inspect what they have produced. So we need to be very fast when we inspect so that they can keep producing and not inspecting and checking on what they're doing.
Yeah.
So speed is very important. So being able to deploy quickly an equipment, scan, get the results. Second one is the accuracy. If you scan quickly, but the results is not certain, not accurate enough to assess and to trust the result, worthless. So speed and accuracy, and that's what's got us close to the Formula One field.
Yeah. Okay, we're going to move on now and talk about another piece of kit on the other side of the stand, and we're going to talk more about automation.
Automation.
Okay, so Aziz, we've moved on now to this piece of equipment. Obviously a robot arm, but explain what it's doing. It's actually operating as we speak, isn't it?
Yeah, actually it's inspecting autonomously a component that needs to be assessed, repaired eventually, or that has been repaired already and needs to be put back into service.
Yeah, okay.
So we're talking more about the overall piece of MRO rather than the on-wing inspection in this case.
So this component, whatever this component is, this has come off the aircraft. It's in a shop now. And this machine can be turned on by an engineer and come and run, they can go off and do something else while it does the inspection. Okay.
Yes, but not an engineer, an operator. You want this to be operated by any maintenance operator. That's a big challenge.
Yeah.
Skill shortage. We cannot afford to have someone like engineering level doing such, I would say, simple tasks.
Yeah. Okay.
And more importantly, nobody's operating it. It's fully autonomous.
Yeah.
And that's the point. Today, MRO runs with calipers, people filling Excel sheets, papers. And what we want to go for is fully autonomous inspection, digitally reported, so you can share the results and record the results in your system.
Yeah.
And also look at it later on to improve your processes.
Yeah. So this is, as well as doing a job very well, it's also helping to the industry with its challenge of workforce, which we know is going to be an ongoing challenge.
Absolutely.
We simply haven't got enough people to do the work that's required. So what these machines can do is make up for that. That's
I guess one answer is really the speed of the inspection task itself. We don't want that part to be staying in a shop, bottlenecks, waiting times, and so on. So we want to automate the inspection so we can check and put it back into service as soon as possible.
Yeah.
The second thing is really skill shortage is hitting us. So we have to solve that. The second thing is really also being able to trace back the results, to look at it how it evolves over time and be able to learn from each of these inspections.
Yeah.
Should we redesign it at some point?
And people talk about the whole life cycle of any asset, whether it's a component or the full aircraft. If you've got that life cycle digitized, you know exactly what's happened through its entire history. And at the moment, it's not really the case, is it? You get an aircraft at end of life, and it is a very difficult job to understand what's happened to that through its 25-year history.
It's also about the end of life of the component itself. So within MRO, we have huge challenges regarding recycling. A lot of the parts, if they're out of tolerance, they are being scrapped because the MRO cannot really assess and would have to go back to the OEM to ask whether that impact is critical or not critical. So they would scrap the part.
Yeah.
Of course, materials can get recycled, but the part is quite expensive. What's happening now is maybe by scanning it, we can really assess if the parts can remain in life for another few years rather than scrapping it or remachine because there is enough material to remachine it and keep it in the air.
Yeah.
So this way we reduce the scrap rate, we increase the recycling, and we keep the air in the planes
So you
in
can
the skies.
repair rather than replace.
Exactly.
Much more so. What about the acceptance of these machines and what they do, you know, in terms of that trust side of things between moving from a human doing it to trusting a machine to do it? Is that journey happening? Is the industry becoming more trustworthy of what these machines can do?
Yes, it is, because the pressure is so strong and the gap between the technology and the processes that are in place today is so big that they can only welcome such type of technology. Of course, you have to go through some kind of trust process where you showcase and you demonstrate the capacity, the capability of the equipment with regards to what is the current process and processes that they know.
Yeah.
But once you've gone through these, let's say, safety assessment and quality and accuracy assessment, then they can only adopt it.
Yeah. And I suppose these technologies can be configured. You set it up for your requirements as an individual company or as an individual operator. So you can then determine a little bit to a degree how it operates.
Completely.
And then therefore the trust comes from that. You have to a degree determined how it works.
Absolutely. You can change the size of the equipment holder. You can change the scanner.
Yeah.
You can customize the software to your own specific infrastructure, your own MES, your own ERP, and the way you want to trace back to your quality management system.
Yeah. Okay, cool. So we've got one more thing to look at, and this is more about the efficiency of your operations. So we'll go over some of the other parts of the stand.
Let's do it.
Thank you. Okay, so this is the final thing we're going to look at is about the actual facilities that MROs, that airlines might have where they get their shops essentially, and making the most out of the space they've got. Because obviously we know there's only a certain amount of capacity out there. You mentioned how demand is exceeding supply. So you've got to make the most of what you've got. This little contraption here doesn't show it off to its best because it's on the stand, but I've seen it working in other places that I've seen you guys, and it can scan it. Well, it could scan this entire hall, couldn't it, and turn it into a digital version of itself.
Absolutely.
And you were saying it's got within 2 millimeter accuracy, which is what we're seeing here. So why would I use this if I'm an MRO or an airline? What's the functionality?
Well, here we're completely on the facility management. You mentioned it. So, okay, how big is my facility? Where are the pillars? How flat is the floor for a new machine coming in? Where is located my aircraft? Which aircraft do I have in which MRO hangar?
Yeah.
How would I rework the layout to become more efficient? My workflow, how many square meters do I have for my financial declaration? So all types of use cases, really related to the facility, the workflow, the asset management, where we use, again, laser scanning, but another type of laser scanner that can scan huge surfaces all the way up to, let's say, 10,000 square meters in 6-7 hours.
Okay. So that's what this will do. You can stick it in your facility up to 10,000 meters, run it overnight. Next morning you come in and you've got I've seen it operate. You can move things around on a screen. You've got that full 3D virtual digital twin of your facility. Yeah. And so I suppose for an MRO, if you've got, say, 3 lines of maintenance, but you could work through this, you could then end up having 4 lines of maintenance potentially in the same facility, which obviously is a massive increase in your capacity. And that's why it's important. Yeah.
So if you want to extend your facility, you want to build a new one.
Yeah.
You can also follow your construction. You can duplicate a line. You can also visit a factory without moving there.
Yeah.
Virtually visiting and taking precise measurement on a 3D model that we have released for you. So long story short, I mean, we send our people, you don't have to buy the equipment. It's going to be a one-time job, right?
Yeah, yeah.
You have 4 options. You can run this on a static. You can fly it on a drone. You can run it on a mobile device. And we give you back a 3D model of your factory with whichever content you want. You want the machine in it. You don't want the machine. Any filtering of water pipes. We can even scan underground to check where your water and electrical wirings are going.
Yeah.
And you can use this 3D model to really optimize, increase your capacity, optimize your floor space, and create new assembly lines or maintenance lines if needed.
So look, you've shown us a lot there in terms of what can be done. Just a final thought on where aviation industry is at the minute. We're at Farnborough this week. You've spoken to a lot of potential customers, I'm sure. Is there an appetite to really embrace this kind of technology now? It's obviously being forced on them through the circumstances we've mentioned. But is there now a real appetite to invest in this kind of technology because it's almost a necessity now, rather than just a good to have? It's a necessity now.
Yeah, no, it is. And I mean, laser scanning is not new.
Yeah.
It's been out there. Of course, we have new products. Every year we launch new capabilities that nobody believed, even ourselves believed could be possible. So we're always pushing the limits. But what's really new is that now this is being accepted. This is becoming usable by anybody. We make it easy to use. We make it fast to collect the data, to analyze the data, to digest the data, to leverage the data, to connect it into a more digital ecosystem so that customers can really use that to keep up with the demand and the growth that's in the market, both in manufacturing and MRO.
And the final thought before we finish, what's on your roadmap for development? You're obviously wanting to continue to push the envelope and to innovate. Where does Hexagon take this in the next generation?
Well, first thing is non-contact inspection.
Yeah.
We don't need to touch the part. We can scan any surface from a long distance with a high accuracy, high speed. Second, we want things to be, I would say, more autonomous. So more automation, more autonomy. Press a button, go to sleep, come back in the morning, get your results.
Yeah.
We don't need to have engineers, smart engineers, looking at a device or holding a device. They have better things to do in aerospace and defense.
Yeah.
They can work on sustainable aviation. They can make aircraft safer and safer, smoother and smoother, more comfortable to fly into, and let the work be done, the inspection work be done by autonomous machines.
Yeah. I suppose for engineers, fears that it takes their jobs away is not really a thing in aviation. There's not enough engineers anyway. So it's not like we want to get rid of engineers. We take more if we could. This kind of technology helps an engineer to do their job more effectively, doesn't it?
Absolutely. You know, we don't hear about fear. We hear about customers asking us, how can I have your equipment do things that I cannot do today because I don't have the engineers?
Yeah. Yeah, it's the opposite problem to most other sectors. But Aziz, thanks very much. It's been really fascinating to see all your technology again. We'll no doubt see you again at a future air show or another industry event. But thanks a lot for inviting us onto your stand and showing us that.
Thank you very much for coming over. Always a pleasure.
Thank you. Cheers.